Alright guys, let's talk about lesson 2, which is identifying a redox reaction. Redox reactions. That is a reaction that occurs when reduction and oxidation happen. And that means because reactions happen because there is a transfer of electrons. So in these kinds of reactions, it's different than what we saw in the last unit where elements switch partners and make new things. It's because these reactions occur when electrons transfer. So elements lose electrons, other elements gain electrons, and they're all within the same reaction. That's what an oxidation and reduction reaction is. So oxidation is when you have a loss of electrons. And the loss of electrons is by an atom or an ion. So what happens is your oxidation number goes up. Your charge increases. And that is because you get more positive charge. Okay, so let's look at an example. An example would be for the metal sodium. Sodium, what it does is that it has one valence electron. So what it's going to do, remember, it's a metal. So metals like to lose their outer valence electron. So it's going to lose this one electron, and it's going to become Na+. We know this. We've talked about this for months now. So sodium loses one electron, it becomes Na+, and then that means that it is oxidized. When it becomes oxidized, it loses that electron and it becomes stable. Na+ is stable because it has a stable electron configuration. Reduction is the opposite. That's when your element is going to gain electrons. So you have an atom or an ion that will gain electrons. Your oxidation number goes down, so it reduces, and it becomes more negatively charged. So let's look at an example. Chlorine and all of your nonmetals like to undergo reduction because, all right, let's look at an example. Chlorine and other nonmetals like to undergo reduction because all they need to do is gain one electron in order to be stable. So they gain that electron, they get a full octet, they turn into a negative ion, and they have an outer shell, so full outer shell, so they're stable. And so chlorine in this example is reduced. So why is it called reduction if you gain electrons? It's called reduction because you gain electrons, because when you gain a negatively charged thing, your charge decreases. So you reduce your charge. Your charge is going to become negative when you gain electrons. So let's look at this example. So we have solid zinc plus H plus gives zinc plus 2 and OH minus 1. What is being oxidized? What is being reduced? So in an example like this, you have to look at your charges. So zinc as a metal, like we talked about in lesson 1, any metal atoms are 0 for their charges, for their oxidation states, and ions have their charges, the charge that the ion is. So zinc loses 2 electrons, so it becomes oxidized. So it went from having a 0 charge to a +2 charge. Remember, when it becomes +2 and it's oxidized, your charge gets bigger. So you go from neutral zinc to zinc +2. Each hydrogen is going to gain an electron, so it's going to become reduced because you're going to have a +1 ion here, and it's going to go to 0, so that means you're going to gain electrons and it's going to be reduced. And those two H's are going to combine and form H2. So here's a trick. Leo the lion says grr. Leo stands for loss of electrons is oxidation, and grr stands for gaining of electrons is reduction. So how do we identify changes in oxidation numbers? The first thing you need to do is you need to assign your oxidation numbers like we talked about in lesson 1, and then you need to determine which species is being oxidized, which one is losing electrons, and which species is being reduced, which one is gaining those electrons. So let's look at an example. We have 2Na plus Cl2 gives NaCl. So first we need to assign oxidation numbers. So Na is a metal and it's an element, so it's a 0. Chlorine's also an element and it's a nonmetal, so it's also 0. And then when we have this compound formed here, Na likes to be +1 and Cl likes to be -1. So now we need to figure out who lost electrons to gain their oxidation state and who gained electrons to have their oxidation state. Well, sodium went from 0 to +1. When you go from a 0 to +1, your oxidation number increases, and when we look at chlorine here, we went from a 0 to a -1, so our oxidation number decreases. So sodium in this case we have to remember, Leo says GR. So loss of electrons is oxidation. Gaining of electrons is reduction. So who lost electrons? Na went from 0 to +1, so Na lost electrons. Chlorine went from 0 to -1, so chlorine gained electrons, so that's where your oxidation and your reduction is happening. So Na went from 0 to +1, so Na was oxidized, it lost electrons. And then chlorine went from 0 to -1, so it was reduced because it gained those electrons. So let's look at another example. What would happen with these oxidation numbers? We go from H is 0, H2 is 0 because it's an element, O2 is 0 because it's an element, and then we have O is -2, and it always is -2, and H in this case is +1. So again, we need to think. We have H going from 0 to +1, O going from 0 to -2. So think, Leo says GR. Who's being oxidized? Who's being reduced? Loss of electrons is oxidation. So H went from 0 to +1, so it lost an electron, so it's being oxidized. And then oxygen went from 0 to -2, so it gained 2 electrons, so it's being reduced. So that's the GR part. So H again went from 0 charge to +1, so it's oxidized. O went from 0 to -2, so it was reduced. So there are a couple of tips when we're doing these, and the one thing you need to think about is for polyatomic ions. So the first thing you need to do is figure out what your charge is, and that is going to be based off of table E. This is the oxidation number, and it's easier than assigning oxidation numbers to a visual atom. So when you look at nitrate as a whole, the oxidation number for nitrate is -1. So spectator ions, on the other hand, are the ions that do not change in oxidation number. So let's look at an example. So we have Cu, which is 0, silver is +1, nitrate is -1, copper went to +2, nitrate's still -1, and silver went to 0. NO3 in this example is a spectator ion because its oxidation state did not change. It's -1 here on the left and also -1 here on the right. So it did not have anything happen to it. So we're going to go over these in class tomorrow. We're going to determine which species are being oxidized and which are being reduced. So we have these 3 equations, and then you also have your check your understanding. When you identify what kinds of things are redox reactions, here's a trick. Single replacement reactions are always redox equations. So anytime you have a single replacement reaction, that's always going to be because oxidation numbers are changing. When you have a double replacement reaction, those are never a redox reaction. Their charges are always going to stay the same on both sides. So something to think about if I ask you whether or not this reaction is a redox reaction or not. You always are going to look for things where you have single replacement reactions, where those are always going to be oxidation reduction, and then you have double displacement reactions which never undergo oxidation and reduction. We'll see you tomorrow.